Good morning to everybody who's just coming in. So today we're going to talk about, actually, I haven't even updated the agenda slide, but today we're going to do a recap, a very short recap of homework 9. I'm not going to get fully into it just because I know a lot of students didn't get a chance to do it yet, but I'll give some tips. And then we're going to talk about something called Socket, which is going to be really cool. It allows you to have real-time communication between your client and your server. And if we have extra time, then we're going to go into databases. So there's just kind of a lot of content to be covering today. Hang with me. I think that this class and the last class on React are probably going to be the toughest classes over the semester, the toughest content to pick up. So if you can get past this, then you're going to be in a much better place. Today we have office hours, 11 with Christiana. I have 3 to 4 and 8 to 9. Yeah, always come there, if things are confusing for you, and I can help out, and so can the TAs. Project 1 grade. So we started grading project 1, looking at everything that you guys made up, and it's looking good. I was so glad to see that pretty much more than 95% of you submitted everything on time. So that's really great to hear. And we should get the grades out in about 10 days or so. So watch out for that. And then milestone 1 is going to be due February 27th. So that is in 10 days, 9 days now. It's coming up fast. And project 2 is worth a lot more of your grade than project 1 was. So definitely make sure that you have been working on it and that you know what's going on. Pretty much if you're doing the homeworks, whether you do it on time or not, that doesn't really matter. But if you do the homeworks, then you're definitely going to have a lot of the building blocks that you need to do most of the project. So make sure that you're working on that. Another thing is you may have gotten a survey from Dr. Schreiber, the chair of the CS department. He was organizing this through Facebook. They basically want some extra data about how the program is going and on the students that they're working with and stuff like that. I'm not going to see the results or the individual results of this. This is for internal program people at Facebook. So don't worry about me seeing it in case you have to say something. But yeah, fill that out by next Monday. You're not forced to, but I recommend that everybody does. And I wanted to give a poll just to see how homework 9 was for you guys. So take a second, look at this. Did you do it? If you did it, how was it? Hard, easy, okay? And again, I wish we had enough time to really dive into React in this class. And you could spend 3-4 lectures on it to really get into what's going on. But I also have a curriculum I have to get through and a lot of new material. So a lot of work is going to be on you to figure out how to use React in the best way. And then also, of course, you have resources outside of class like office hours and Slack. Okay, 92% have voted. 2 more people. Okay. All right, so looks like 39% didn't do it. That is a solid amount. And then 42% did it and it was hard. So I think that's kind of the clear majority. A lot of you are saying that you need more time. I think based on what I'm hearing and how many people weren't going to be able to do it, I will look into extending the deadline for you guys, and I'll put that on Slack once I decide when you can turn it in by. Stayed up really late doing that homework. Okay. Okay. All right. Yeah. So that's okay. That happens. And I know that you guys have a lot more going on in your life too. So I will message on Slack about that. That's okay, Lasha. Looks like there's a small percent of you, 20%, that said it was okay or easy. So, that's good for you guys. Okay. So I wanted to go through some things just very quickly. The first point I wanted to make with React is that when you're adding a state variable, you don't only have to store an array for that state. So that was just the example that I showed where I wanted a to-do list, and a to-do list is a list. So you kind of want to store a list of things that you're adding to the list. But you could have all sorts of things that you want to store. So you could have a number, you could have a Boolean, anything you want. In this case, in its example here, I'm storing a number because I initialize it with 0. And I'm going to call that number count. That's the name of the state. And then this function set count just allows me to update that state. So I could say set count and then pass in 1, and then the state would change to 1. So always think about like any type of data structure you can use, whether it be like an object or other things as well. Steps 4 to 5 is where it started to get confusing. Okay. Another thing is I saw that a lot of you were writing your use state in app.js. You don't necessarily have to write your use state in app.js. You can add your state to any component you want. So this can be in board, this can be in like your box or square component. It doesn't matter, but where you do it should probably be the place that you're actually using that state and updating that state, just so it's easier. Otherwise, you have to pass things down into like children components and things like that. And I think there was a little bit of confusion also with like hierarchy, like how you kind of render components inside of components. What I'm kind of expecting is that app.js is just your root component. Like everything that's kind of rendered goes inside of there. And within app.js, you can render your board component. And that can be the one that kind of like is tracking the state of the board, where clicks have been made, things like that. And then that can then render another component, which is called like your box or square. It doesn't matter what it's called. And here you notice that we're repeating the similar UI 9 times across this board, where there's a square and there's either like an X or an O in that square. So that's a good opportunity to abstract that out to create its own component for that. And you can kind of pass in some value, like whether to show an X or whether to show an O. And that allows you to reuse the logic of one square 9 times across the board. So what are some things specific in React that have been confusing you guys? Is there like some concept or something that I can touch on, like just in the next 3 minutes? For all of the people that said they did it and it was hard, why don't you chat me like a reason why it was hard? How to pass variables to a function. Okay. Changing the array immutably, passing variables dynamically between different components. Okay. What else? How do you change the cell value from null to X? Index key to your onClick function. Okay. How to pass a function as a prop. Const. Okay. 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 Updating the array after the click. Okay. Okay. I'm not going to go into every one just because there's no time, but I'm just going to kind of take into account what you guys are saying. One thing I'm seeing is, how do you pass in a function as a prop? So passing in a function as a prop is no different than passing in a variable like any other kind. So you could just have whatever variable you want. It could be a 0, so just a number, or it could be a function as well. So you could say function, blah, blah, blah here. But even this right here, when you define a function here, I'm calling this function update count, and that's its variable name. So whenever you want to pass something down further, all you have to do is pass in that variable name. So let's say I have a board component and I want to pass in some function, and let's say that's update count. So you're going to pass in a prop. The name of the prop can be whatever you want. I can say this is going to be my function prop. So that's the name. I just made that up. And then in curly braces, that's how you pass in any sort of like JavaScript variable. So there you just put in the name of the function and you pass it in as a prop. Now, let's say that now I'm in my board component. Let me just save this. Okay. So now let's say I'm in my board component. You always have to take in this argument props whenever you are kind of taking in any props, whenever you're passing them in from here. So I passed in a prop called my function prop, and that is going to be the function that I can then use to do something. So let's say I want to pass it as an on-click handler. So I want to run this function that I'm getting from props every time that the div that I'm creating here is clicked on. So for that, you would just do props dot, and not update count actually, you do props dot whatever this is. So props dot my function prop. And what this is basically saying is once I've clicked on the div that is being rendered here by the board component, then I'm automatically going to call this function, whatever it may be. And it's going to take me here to update count, and it's going to basically want me to run whatever this is. So this is setting a count. I think one confusing thing though that you might see is like it wants this function that I've written here, it actually wants an argument. So actually, let me just close this for now for clarity. Take this away. Let's show you here. Okay. So sometimes you have a function that wants a certain argument. In this case, I want to update my count. I'm setting a count state, starting it at 0. And I want to change the count in this function from whatever it was before to what it was plus however much I want to increment it. Now, I'm not actually defining how much I want to increment it by here. When I'm passing in the function, wherever it is, if it's in another component or it's in the same component, wherever it is, then it's expecting that if you're going to call update count, then it needs some sort of argument. So I can't just do update count here on its own, because this is implicitly not going to be actually giving it some argument that you want. If that's the case, then you basically are creating a new function here. Again, no arguments, because this is implicitly not passing in any arguments that you really care about. And in that new function, you're basically saying, I'm going to run this function, but with a specific argument. In this case, update count 1. And when I click this button, then it's basically going to update the button by passing in 1 here, and then setting the count to previous count plus 1. But you could change that. So I'm calling this, I have a second button right here, and I'm also passing in the same function, but with a different argument. And that is what allows me to not add it by 1, but subtract it by 1. So then when I click on that button, it's going down. And when you're doing kind of your squares and your tic-tac-toe, think about what we're doing here, because each box kind of, we want to have a certain index, maybe 0 through 9. And for each box, we only want to pass in a certain index. And this is kind of how you can think about how to know which index you want to update. in your tic-tac-toe board by manually setting, like for this square, I want to set it to 1. For this square, I want it to set it to 2, and so on until 9. Any questions about that so far? Okay, glad to see that helps, Andre. I want you all, whoever thought it was tough, definitely go through your code again from homework 9. And I'm gonna post this on, I'll just like send it to the class on Slack or something, and look through this. The more examples you see, slowly you're gonna start seeing patterns and it's gonna make more sense. All right, but now let's move on. Let's go. Oh, Shantanu, you have a question? Sure. When I say use state 0, yeah, so this is initializing it the very first time that I create this component. It's setting it to 0 because it needs some default value. 0 doesn't matter though once you start interacting. So once you start doing stuff, it's not going to remember 0 anymore. It's just going to remember the last value that it was, like the previous count. So that's 8 now. And it's going to be doing whatever logic from 8 and starting from there. But 0 is just basically saying when you refresh for the first time, where are we starting? All right. And again, just look at more examples, read through documentation, things like that, and things are going to add up more. You're not going to have everything you need just from my lecture and my demo, because I'm just giving one example there, and you need a lot more to start seeing the patterns. Okay, let's keep moving. So I wanted to also give a few tips on how to get started on project 2, just because the deadline is going to be coming fast. So you should have cloned the React Starter repository for homework 8. You should have been working within that repository for homework 9 when you were testing out your tic-tac-toe components. And this is great. I think I actually want you to build all of your code for project 2, starting from your React Starter repository. So from there, you can basically clone it. You can do what you want, and then you can push this code now to your own repository by like setting its remote URL to your private repo. I put some instructions on how to do that in your specs. Also, all your changes should be on the milestone 1 branch. That should have like all of your final code basically. I don't want you doing anything to main. So I want you doing it all on milestone 1. We're going to be grading the milestone 1 branch. Once milestone 1 is over, then you can work on merging those changes into your main branch, and then branch again off main to start your milestone 2. So only worry about your milestone 1 branch when you're doing this, and think about it as your main. You're going to push that branch to Heroku. You're going to push that branch to GitHub. You're going to do all of that, and that's how we're going to see all your code for that milestone. And yeah, so you should be starting by doing homework 9. This is going to start you with a local game of React. I also put a useful tutorial on that homework where how you can kind of set up the rules of the game and things like that, calculate the winner and things like that. And then once you've gotten that local game working, just like on your own browser, then you can start doing the networking side of things. So we want this to be a real-time online game where you play with other people. This is kind of going to be what you start in your homework after this class when we do socket. And then again, you need to make sure you do research on your own. You're reading docs, you're watching videos, and that's going to be what really helps you. Another thing, I'm going to mention this a few times, but you might be running out of space on Cloud 9. You might be seeing errors about this. This happens. This happened to me too. If you get that, then first try this link where you can try to resize your environment and make it bigger. That's probably the easiest way because you can keep all the stuff you have on the same workspace without having to move to a new one. After that, if it's still not working out, sometimes it won't, like it didn't for me, then you'll just have to make a new workspace. And that means that you should have all your things backed up, like your code and stuff, on GitHub. And you might have to rerun and reinstall some packages that let you use everything again. So I put some things that you may have to do in order to like customize your workspace again, so it's ready to code on. This is mainly just so you can look at this slide if you're running into this issue later. Okay, and now let's actually get into the meat of today's topic, which is socket and like real-time updates and networking. So what client server architecture have we been using in project one? Does anybody know? How have we been getting data? How does the client ask for data and get back something? Flask is our web server. That's the server framework. Yes, so the client is making a request, Abram, and the same. Yeah, so HTTP, that's actually what I'm looking for, is the model that we're using right now. That's basically a request response model. The client is sending a request. So this is going to be a URL. This could be like your Heroku URL. This could be your local host URL to our web server, and that's Flask. This server is then returning back some response when it gets a request. So if you're hitting the main / endpoint for the URL, then it's going to return back a web page or like an HTML page. Or maybe it's going to return back some JSON, some just like data to our client. And if you remember, I had made this little diagram here, but this is kind of the client server architecture that we've been doing. The browser makes a request to Flask, Flask gives a response. Flask makes a request to Spotify, Spotify gives a response. So that's kind of the way we've been thinking, and that's the way that most apps and most normal architecture is. But this can also be limiting. So right now, you're only getting a response when you ask for a request. So I have to say, hey, can I have this? And then they'll be like, okay, cool, yeah. Why do you guys think this can be limiting? What's the issue with only being able to get something back when you ask for it? We need to save things. What kind of things do we have to save, Oscar? Users. Okay, so I think something you're getting at here is that your request response model is what we call stateless. So the server is not going to remember who asked for something. It's kind of only just going to give a response blindly when it gets a certain request. And that could put more work on the client side to remember who are your users and things like that. You might not be able to get data updated on the server, Nicholas. Yeah. So say in a game, someone moves the server, needs to send you, yeah. And yeah, that was what I was getting at with sessions, Kevin. I think Nicholas actually is saying kind of what I was thinking too. So if you only get a response when you ask for something, then you're not necessarily getting the fastest updates. If you think about like you're kind of chatting with somebody, and the server knows when somebody has added a new message to your chat when they've sent a message, but you haven't actually gotten that message unless you ask for it. So if you have it in that sort of form, then you're not getting real-time updates. You're only getting updates when you ask for it. And there's a few other limitations going on here with this model. One is that this is centralized. So you need a server. You're not going to get a response if the server is down. You're kind of all relying on the server to be running in order to get data back and make your app work. The alternative to this is something you could call a peer-to-peer protocol. In that case, you don't have a server, you're kind of just running everything in a decentralized fashion where the clients are all talking to each other. I don't know if you've seen Silicon Valley, the show, but they were actually working on a peer-to-peer product when they were trying to make like the internet that was decentralized. The other limitation here is that this request response model is kind of one way or unidirectional. And this means that only the client can make a request to the server. And this is kind of what Nicholas was talking about. The server doesn't have any way that it can just talk to the client unless the client has made a request. So maybe the server has some new important information and it needs to give it to the client. Maybe you got a new notification or a new message. Then unless the client asks, it can't talk. So this is why you can't do real-time updates. And Michael, yeah, so it is exactly the difference between a forum and a live chat. You don't want to have to refresh, which is kind of asking the server for new posts or new updates. You want them to just pop up on their own as they're coming. Is there a way that this could be affected like an attack? Yeah, so in the request response model, because it's centralized, you have a focus place where you can kind of try to make an attack. So if you see a hacker or something, they might go for the server and try to break it down by maybe making like 1,000 requests to your server to overload it. If something's decentralized, then there's no one place that you can attack, and it becomes a lot harder to focus your energy somewhere. We're not going to be talking about decentralization in this class because nobody really does it in software engineering. That is more something that is kind of cutting edge research side of things, but it's pretty cool to think about. So what apps do you think that are only possible when we're doing real-time networking? I'll give the first example, tic-tac-toe. So for project 2, unless you have real-time networking, you don't want to have to keep asking, oh, did the other player make a move? You just want to know automatically if the other player made a move and see that updated on your screen. Otherwise, if you have to keep asking every 1 minute, then that's just a really painful way to go about it. Yeah, so any messaging app, any live chat app needs real time. What else? Mina said ride hailing. So maybe you need to know where the other car is and watch it move on your screen slowly as it comes to your house. So you can't do that unless it's in real time. iMessage games. Yeah, so you're playing against somebody. Any type of game that you're playing live with people. Data streaming. So when you're on Netflix, you don't have to keep requesting, hey, can I get the next 5 seconds of this movie? You want to somehow be able to stream the entire thing as it's kind of being served by their server. Chess, there's other games like that. What else? What about Google Docs? You're writing something on a screen, it automatically updates for somebody else while they're on that Google Doc. So you need real time right there. UDP request. I don't want to say yes or no because I don't actually know. You might know better about the protocol stuff. Maps, yeah. So if you want some real-time like traffic data or something from maps, that could be one, Chris. And then maybe something like stocks, like imagine a stock market app and it's giving you real-time updates as prices are changing or something. Any sort of data that's kind of working in a much faster pace. So there's a ton of cool things that you can do in real time, and request response can be limiting for those. There's a few different ways you can kind of address this. One is something called like polling. So the client can basically keep asking for new information every so often. We're going to get into that. There is streaming, where you're kind of maintaining a persistent connection between the server and client. So there doesn't need to be any asking, and some other things. I'm going to talk about 2 of them though. So with polling, we can basically have the client repeatedly pull the server for updates and by sending it lots of requests. This ensures that, if you do it every second, then the chances are that you're going to find out if somebody messaged you pretty fast. This is similar to a child saying like, are we there yet repeatedly? And every time the parent just has to say no. There is also the concept of a long pull. And this is basically similar, but the client is going to send a request. It's not going to have to keep sending requests. The server is only going to give a response back when it actually has something to say. And this can be like a child telling the parent, I'll tell you when we get there. And then they're just kind of long pulling, waiting until the parent finally says, okay, we're getting there. This is a little more efficient because the child doesn't have to keep asking, are we there yet? They can wait and know that once the server has something to say or the parent has something to say, they will say it and they can take it. And the other option, this is kind of the more modern option, I think since like 2008 or so, there's this new protocol called WebSockets. And this is basically a two-way connection that's open between the server and the client. You don't need to send a request anymore in order to get back information from the server. So whenever the server wants to say something, it can simply say it. It doesn't have to be asked in order to do that. And this is where you're going to see like the best sort of real-time protocols are coming in with WebSocket. But either way, like actually when we're doing things, then we're not going to be using WebSockets because on our Create React app, we're already using WebSockets to have that live editing where when you save, then it automatically builds your files and shows you the newest version. We're actually going to be doing what we call long polling, the better version of polling. But this is all going to be kind of abstracted away from us with something called Socket.io. Either way, it's going to feel like real-time networking, and we don't have to worry how it's happening under the hood. And yeah, either way, instead of requests and responses, our new kind of line of thinking is going to be that things are going to happen only when other things happen. So not necessarily when you ask for a request, you get a response. This is what we call like an event-driven protocol. We're only dealing with like events, and an event can happen from the server to the client, even if it didn't get asked. And an event can happen from the client to the server like normal, whether it's asked or not. This is going to be similar to request response, but the difference again is that, well, one, the server doesn't need to make or doesn't need a request in order to say something. And then two, if the client says something, then the server doesn't even need to say anything back. It can just kind of say noted and do whatever it wants to do. And this is where Socket.io comes in. So this is a library that is enabling what they call real-time bidirectional event-based communication. And this saves us from having to write all sorts of annoying code that manages this real-time connection between the client and the server. It has a bunch of different libraries across all types of languages. So it's a useful thing to know just for like your personal projects and things like that. Regardless of the stack you're on, they usually support it. For us, it has a library on the client side in JavaScript, and then a library on the Flask side, actually, directly to use it in Python and Flask. All right, so we're going to be doing a demo where we basically set up a basic like socket connection between client and server and see how real-time updates are working. I am going to send this link on the chat. And I want you all to take 5-6 minutes and follow these instructions to install Socket on the client and the server. Basically open up your files in React Starter and replace the code I've written here, or replace your code with the code I've written here, and then run the code. And then we're going to talk about it together. So in the demo, you're not going to need to write the code and follow along. I just want you to pay attention to what I'm saying instead of what I'm writing in the code itself. So take 6 minutes. We're going to come back at 9:44. And once you've gone through all of the steps in this list, then just give like a thumbs up reaction so I can see slowly like how many people are done and whether we can move on. Okay, one more minute. Are we still working? Are we done? Michael's ready. Anybody who's ready, just private message me. Okay, no module name Flask cores. You might need to install that too. Let me see. I think you can just try pip install flask underscore course. Okay, I'll give one more minute. Okay. All right, here we go. So have everything open, and I just want you following along and paying attention to what's already written and what I'm saying. And you can like play around with the app as we're doing the demo. Okay, so hopefully you followed the instructions. You have your app.py code copied into the file and your app.js code copied into this file. And we're working in our React starter directory just because that has this whole environment that allows us to use the Flask backend, this React front end, as well as the framework for live editing and all that. And then hopefully you have your Python app running with Python app.py, and then the front end side of it with npm run start. Now we are going to start by just previewing the application and opening this up into a browser. And I want you to open this up into two different tabs. So just copy paste that URL, and you're going to see why we want to do that. Also open up your developer tools in both of the tabs because we want to be able to see any loggings that are happening. Okay, and I'm going to close the preview here just to make the terminal bigger on my Cloud9 itself. So when we open the preview, what are we seeing now? We're seeing just a header with chat messages, and then an input where you can enter a message and then press send. So it's not too different from our to-do list where you had an input and then a button that you clicked in order to add to the list. But now we're going to be using some client-server networking, specifically using like socket.io to pass data around. All right, so a socket connection basically is this bi-directional connection where between the server, which we're talking about is app.py on the Flask backend, and then the client, which is kind of what our browser is running, so our JavaScript code, app.js, they are able to talk to each other, but bi-directionally. So the server can talk to the client can talk to the server. And the client doesn't have to make a request to get some data back. The server can just push data to the client on their own. So let's start with the server side of things and just look at these new lines of code that are showing up in here. At the top, you're going to see we're initializing this variable socket.io with some stuff in it. You don't need to worry too much about it. Just know that You can look this up and in the Flash socket IO docs and see like what exactly it's doing, but it's kind of initializing this socket variable that we're then going to use across the file. Also, if you see at the end, we're calling socket.io.run now. We're not calling app.run, which we've done in the past in order to execute the server. But we are passing in app as an argument, which is basically going to serve as a wrapper to execute our server, but using the socket system that we want. So when a client basically connects to the server and establishes a socket connection, then it's going to emit what we call a connect event. So if you see here at the top of your app.js code, we're creating this variable socket and calling this function IO. When you call this function, then that is going to basically connect to the server that is running. And when that happens, then a connect event is basically sent to the server, and it kind of knows that a user or a client has connected to it. So let's see what's going on over here. At socket.io.onConnect. This kind of looks similar to what we have in our routes. So whenever we want to say like, I want to serve this data at this endpoint, then we would say app.route and then / whatever we want to serve it at. It's a little similar, but not the exact same. We're not serving it at a certain endpoint anymore because we're not doing the request response model. We're talking about an event-driven protocol where we think of everything in terms of events instead of URLs and endpoints. So what this is saying is our server is basically listening for a connect event, which happens when a client connects to this socket connection. And when it kind of hears that event, it's going to run and execute this function below. So this is called onConnect. It could be called anything. And we're simply printing that a user has connected. So actually, if I scroll up in my logs in my terminal on the Python side of things, you're going to see user connected being printed out here. And this is when I was opening up my preview, and I actually opened up 2 different tabs, as well as this mini preview that you were seeing at the beginning, which is why we're seeing 3 different user connected logs coming out in the terminal. So this means that each browser that we have here is actually acting as a separate client that is connected to your server. So we have 3, and I closed one. So now we have 2 different clients or 2 different users that are separately connected with socket to your server. And this could be the same as maybe you're playing a game against your friend who is like 10 miles away on their own computer. It's the same as if you opened up 2 different tabs on your single browser. Cool. So the connection is made. Now let's actually do something. So let's see what happens when I put in a chat in my first browser. So I'm just going to be like, hey, and then I'm going to send. And here, the hey is kind of popping up on the list, which is great. I actually had some code to, similar to our to-do list, basically just take anything I press and then render it here on our screen. This is all local on our current tab, but how does this work if we want to transfer this message to everybody who is on this kind of chat room? Well, if I open up this other browser tab, then you see that hey was not actually typed in here or done anything, but it's popped up here in the list of messages. And if you look at my logs, I also have something saying chat event received, and here is the message. And let's send something back. So I'm just going to say yo and send. So yo is showing up here. That's expected because it was kind of local. But if I go to my first tab, then yo is also here. And here I see chat event received. and the message was yo. So it's not like on the one that I sent yo on, I'm getting chat message received or anything. So only the other client actually received that message from the server. So this is pretty cool. We have like a chat room working now. And now let's see how this actually works under the hood in our code. So let's start with the server. Or actually, no, let's start with the client because that's kind of where we're doing some action by typing in something and pressing send. So if we go down to our HTML, we have some stuff being rendered. We have our button here, and we have our input similar to before. When I click the button, then we're basically calling this function onClickButton, and that is going to be called every time I click that button. So let's see in this function what's happening. I am basically checking if my reference is null. So hopefully it's not because I have set my reference to the input in this line of code later on. And then I'm grabbing the actual message that I've typed in from that reference. So from that input HTML element, you do .value in order to get its text. And then I am simply kind of updating my state variable called messages. This should look really similar to our demo. And updating this using the useState function to update my state variable. I'm taking in the previous value of my state. I'm making a copy of it, but adding in messaged along into this array. So my new message that I just typed in and pressed submit for, that is being added on and tracked in our state variable now. And that is kind of why this message automatically popped up on our UI, because here we're mapping out every single message in our state and returning a kind of a little list item for that given message. So that's cool. That's kind of expected. And that's what we were doing in our to-do list last class. But there is this next line of code, which is actually the key to allowing other browser tabs to be able to see that message that you sent. This is socket.emit. So I'm emitting an event. The first argument is the name of the event. This is called chat. I set that. And then I'm passing in an object with only one value here called message. The value of that key for that key is the message that I had gotten from my input. So whatever I typed in. This object could have all sorts of data in it. So I could call it like other info, and then maybe I want to pass in an ID. Maybe I want a username, and then I'm saying like Numet. So I can pass in all sorts of information here as a part of this chat event that my server is actually going to read. So when you emit this message here from the client, then there has to be somebody on the server side, so your server, listening for that specific event. So I called it chat. If you look here, I actually have a route set to socket.io.on chat. So you have to make sure these two are the same. And whenever the client is emitting this event and the server catches it, then it's going to run this code here. So what's it going to do? It is simply printing out data. So as you can see here, it's taking in an argument, and that argument is basically whatever you passed into the event here. And again, this can be all sorts of information that you want. In this case, it would just have the message. So we're printing that out. Let's make sure that that actually showed up. Let's look through these logs, scroll through, and I actually see message, hey, message, yo. So we were successfully got that event on our server and printed it out. And then we are actually emitting event after we heard this event. So we heard one client say chat, and we actually want to emit chat to all the rest of the clients out there that are on our connection. So all those other browser tabs, in this case, my second tab, we're sending out an event from the server now to the client. And we're similarly doing socket.io.emit. The name of that event is chat. I'm passing in data. So here I'm actually just passing in whatever I got. So the same exact argument, I'm just passing it back down to the rest of my clients. So I'm not changing it here, but I could pass in anything I wanted. If I wanted, I could just be like, say something else here, like message intercepted. And this here would not actually take into account what you got in your argument, but just send something else. But I don't want to do that. I actually want to send the right message that somebody passed up. Broadcast equals true just means I'm broadcasting this to all of my all of the clients. And then including self equals false. I'm saying false here because whoever sent this chat event, whatever client sent that, I don't want to send back down a chat to them about this. They already know that they sent up a message with chat. They already see it on their screen. So there's no need actually to be sending it to that same person. I want to just get all the other people out there who are on this connection. Any questions so far? Is there something that's confusing you in the code or something you want to clarify? Ian, you're good? Cool. Okay. All right, Shaska, you're good. Let's keep going. That's what this line of code is basically saying. I'm listening for an event, and then I'm actually emitting out an event here. And the beauty of this sort of model is that I can emit an event even though the client didn't actually make a request. So the client doesn't necessarily know that they're getting back a chat event at a given time. They don't know that somebody has sent a message. They don't know that somebody has made a chat at any specific time. They're completely kind of agnostic of everything going on somebody else's computer or browser tab or whatever. But this method here is actually pushing something from the server to the client. So whether they ask for it or not, they're getting a new event that they can then use for their information. So here, if we go back to the JavaScript, we updated our own state inside of this component whenever we, as the client, sent a message. But how did the other clients, how did my other browser tab know that there was a new message sent? And how did it update its UI accordingly? Well, we know on the server side that the server emitted back this event, chat. But how does the client catch that? This is actually this big line of code right here. So you're going to see socket.on, very similar to socket.io.on on the Python side. And now the client is actually listening for a chat event. So before we were talking about the server listening for an event. Now the client is listening for an event from the server. So any emitted event from the server side, the client is listening for. And if it hears that event being emitted, then it's going to run this function right here. This function takes in one argument, and that is whatever data that is being passed down right here that's being emitted. It doesn't have to be the same word. It's just assuming whatever that argument is, I'm taking that and I want to do something with it.
Hello.
So here, if I do receive a chat. Hey, what's up? This is Paul?
Hello.
Yeah. Hey, Paul. I think you're unmuted. Okay. Let's keep going. And then I'm going to log this message and then log the data that I'm getting. And this is why in your tab, you were seeing chat event received and then this object, which was the message from the other person. And then finally, to actually show it on the UI, again, I have my state, which is keeping track of all the messages I'm seeing on my screen. I want to add the messages that somebody else sent onto my screen here, which is why I'm doing set messages. And then again, the same sort of flow that you would see if you sent it yourself. So this is how this list is going to store all messages that are being sent on this public chat room. In real time, it's going to be updated. One last thing I want to mention is we're putting this inside this funny use effect. Use effect is basically another React hook similar to use state or use ref. So it's this helper function. And it's basically saying, first thing is it's taking in two arguments. One is a function, which you see here. Two is an array, which here is empty. So what use effect does is it allows you to say when you want to run a certain amount of code in your React component. In this function that you passed in, it's only going to run this function when the array here has some variables that have been updated. So let's say that I put input ref here. That would mean that this function would be executed every time the variable input ref changed. Maybe before it was null and now it's some value. Then when that change happens, then this code is executed. And this is kind of like a side effect. Like if some value is changing out there and I want to know that and run some code when that happens, then you can put that in use effect. In our case, it's an empty array. This basically means that we're only going to run this once. We're not going to wait for anything to update because there's nothing in here. And we're only going to run this when the component mounts, so that first stage. And we're putting this function here because socket.on is basically just establishing this listener for the event. And we only need to establish that we want to listen to chat once. And then the component knows that after that, we're constantly listening for it. And every time that we do get the event, we are going to call it. But what this is saying is we only want to establish this sort of rule once in our React code. And you can put those sorts of things in a use effect. So that's it. And hopefully you have a very basic idea of how real-time communication works between multiple clients and the server. Okay. So this is how this list is going to store. So any questions so far?
So you need the use effect to like essentially subscribe to that event, or can you just put socket.on out of the use effect?
Right. So that's a really good question, Michael. If you can just put the socket.on outside of the use effect, but it's kind of like a waste. So this is more of an optimization because we only need to establish this listener once when the function is like first created. You don't need to establish it every time the component updates. So if you were doing it outside of the use effect, then every time you get a new chat message, and that's kind of like updating the component to show the new message on the UI, then you're going to be reestablishing the same exact listener. So it's just kind of inefficient to keep reestablishing the same thing because it's never changing. The logic here is never changing. Does that make sense?
So app.js runs every time the UI gets updated, or is that what you're
Yeah.
saying?
Yeah. So for any function component, doesn't have to be app. It could be your board. It could be your square. It could be your button. Whatever that component is, basically what's happening is whenever either the state or its props are the arguments, whenever either of those two things changes, then this whole function is rerun from start to finish. This is what allows you to update the UI automatically. So in the case of our messages, when a new message is added to this array, then we're basically running everything underneath all of that code again. And that's what allows you to render the new version of messages on the UI and show that update. This is all happening automatically, like behind the scenes with React.
All right, I got it. Thank you.
Yep. And so who can tell me then, I basically have two set messages, right? On line 18 here in onClick button, I am updating the state variable to add a new message on. And then in line 34, again, I'm calling set messages to update the state variable with a new message. Why do we have two of them? What's the difference? Can somebody tell me?
Yeah, I think the on-click button is for updating your own message that you're sending. So, because in the app.py, you're only broadcasting it to everyone else but yourself. So you have to do it yourself essentially for your own messages. And then the second set messages is for receiving other messages.
Exactly. Yeah, thanks, Michael. So one is exactly for the self when you send something. The other is when you're receiving. And I see John said the same thing in the chat. And the reason we're doing this here is it's again, it's just more efficient. So when you've sent the message, you already know that you've sent it. So it's a waste of time to wait for the server to give you back some information and then render it on the screen. Because locally within your React, you already know what you've sent. So you can immediately put it on the screen instead of waiting for this event to come back from the server. All right. Okay, I'll post this on YouTube. You guys can slowly read through it again and listen to it as well. Okay, so now I want us to take the way that we've been thinking about this and just apply it to our project to work. So you want a real-time tic-tac-toe board, right? Whenever somebody makes a change on the board, then it's similar to sending a chat message. You want to automatically update your screen so that you see their turn on your board. So we're using this sort of event-driven protocol. So that's what you saw where you do like socket.on. When an event happens, you're listening for an event, you're going to execute some code. And maybe that includes pushing an event to all the other people that are, all the other clients that are on your app. Some events that you kind of got to be thinking about in project 2 are basically when a user is logging in. So I call this login, but it's a very simple form of it. All they have to do is enter in their username, and then they'll be able to see the game and do all that. So when the client enters in their username, when some user does this on their tab, then what we want to happen is the server to basically somehow be tracking the active users in a session. And then let all of the other clients know that someone new has joined the room. So you usually see it in a public chat room, it'll be like, this person has joined the room, and then it'll say it on the UI. So that's kind of the way you want to think about like a new login event. When a user or a client kind of disconnects from the server. So this could be when they close a tab. I didn't show it in the demo, but if you closed one of those tabs, then you should see in the terminal user disconnected printed out because they've lost the connection. So again, you want to be updating that list of users who are active when somebody leaves as well as joins. And then kind of the key to like the actual gameplay is you want an event when somebody clicks on the board to play their turn. So the client somehow needs to tell the server with an event that it's clicked the board and where it clicked, which square. And then the server then has to let all the other clients know by pushing an event which turn was played. So this is kind of what this last part about clicking on the board, that's going to be your homework 10. I want you to basically implement that in Socket with the app that you started working on in homework 9. And homework 9 plus homework 10 together is going to give you a very, very MVP version of what you need for project 2. Okay. Any questions with socket? And likewise to React, you might not have everything you need for project 2 with socket. You might need to do some research on your own in like the Flash socket IO docs, as well as like the socket IO client docs. And only then, like once you start playing around with it, like Andre said, are you going to have a better understanding. Okay. I'm going to, let's see. Okay, yeah, I think we only have 5 minutes, so I'm not actually going to get into the next topic, which was going to be databases. I think we can just start covering it next class. Part of your homework, though, is going to be installing all of the things that you need in order to work with databases, mainly Postgres, SQL Alchemy, things like that. So you're going to need to do that. But I'm sure you guys are tired, so I think I'm just going to give you 5 minutes back and send you off now. Oh, okay. Canvas says that homework 10 is locked. I will fix that right now. Thanks, Pranavi. So yeah, before next class, by next Tuesday, finish up homework 10 and implement the socket stuff. I will extend the deadline for homework 9 to Sunday night. So those of you who couldn't finish it, you can still get full credit if you do it by Sunday night. And for those of you who did finish it early, I'll give you some extra credit for doing it on time. So make sure by next Tuesday, you can do homework 9 and 10, because those are like really key to your project too. All right, that is everything. Start working on project 2. Next class, we will cover databases more deeply. I'm staying on if people have questions for 10 minutes. But otherwise, have a good weekend, guys. Hope you get some rest. Hope you get some more time and things like that. Thanks. Bye, Jessica. Stay safe. Bye, Chris. Bye, Andre. Ian, if you want to make some changes, you can totally resubmit by Sunday night. You can do the extra credit if you want to. Bye, Pranavi. Yes, and yeah, same thing. You can resubmit. So resubmit once you've done everything fully. Okay.
Hey, Professor, I got a quick question for you.
Hey, Giovanni, what's up?
I see that these lectures are recorded, but I couldn't find them on Canvas because I actually happened to miss the first 30 minutes.